Okay, good day everyone. So we will be discussing today about hydrostatic force in marine engineering. So these are the hydrostatic force. So hydrostatic force refers to the force exerted by a fluid at rest on a submerged surface due to the fluid's pressure. So the force is a result of the hydrostatic pressure exerted by the liquid at different points on the surface. So this pressure is dependent on the depth of submersion and the density of the fluid. So hydrostatic forces are important to understand because they affect a wide range of marine structures such as the hulls of ships, underwater tanks, and submerged platforms. So the pressure is exerted uniformly in all directions and increases with depth. So before discussing hydrostatic force, it's essential to understand hydrostatic pressure because the force is derived from it. So hydrostatic pressure at a given depth below the surface of fluid is given by the formula density times gravity times height. So this pressure increases linearly with depth, meaning that the deeper you go, the higher the pressure exerted on the submerged surface. So on our pipelines, we also have a hydrostatic testing. So it is a test to ensure that there will be no leakages on our pipelines during usage. So hydrostatic testing is just like putting water in it or putting air or something or any fluid you put inside, and then you close all the valves, and then you just wait that until a specific time that there will be no pressure loss. So if there is pressure loss, it means that there is a leakage on your pipeline. Okay, so hydrostatic force is a result of the pressure acting on the area of the submerged surface. So the total hydrostatic force of the surface submerged in a fluid can be calculated by the following formula. So hydrostatic force is equals to average pressure times the area. And for a vertically submerged plane surface, the average pressure is given by density times gravity times height of the center of gravity divided by 2. So that is the formula. Take note on our formula. So example, so let's calculate the hydrostatic force on a vertical rectangular plate submerged in seawater. Consider a plate of dimension 3 meter high and 2 meter wide submerged to a depth of 6 meters. So the density of water is 1025 kilogram per cubic meter. With the use of the formula of average pressure, we have a value of 30,000 Pascal. And then using that value to get for the hydrostatic force, so we have a value of 180,000, more than 180,000 Newton. Okay, application of hydrostatic force in marine engineering. First, ships, hulls, and submerged surfaces. So application, hydrostatic forces act on the hull of a ship, affecting buoyancy and stability. So example, the pressure distribution along the hull increases with depth, influencing structural strength and stress concentration in submerged sections. So for ballast tanks, for non-ballast free ships, application, traditional ships use ballast tanks to control weight distribution. So hydrostatic forces inside ballast tanks ensure even weight distribution, maintaining ship stability and reducing rolling or pitching in rough seas. For firefighting systems, uses hydrostatic pressure to distribute water through fire hoses, sprinklers, and deluge systems. So pressurized water is pumped through pipelines, ensuring a constant supply for firefighting operations. Why are they on the floor? Okay, next, submarine and underwater vessel pressure hulls. So submarines and deep sea submersibles experience extreme hydrostatic forces. So the hull structure must withstand increasing pressure as depth increases, requiring reinforced materials and hydrostatic pressure calculations to prevent collapse. So in this type of submarine, we have double hull. So double protection, and then can withstand higher pressure. Fuel and lube oil storage tank. So if this is your tank, hydrostatic pressure determines fuel or oil levels in storage tank. So pressure sensors measure the liquid column height to calculate the volume of fuel or oil in the tank. For dams, locks, and marine gates on our dry dock, so hydrostatic force calculations are essential for designing structures like dry docks and canal locks. So dry docks use flooding and drainage to lift and lower ships, relying on hydrostatic pressure control to maintain balance and safety. Another application is for pumps and hydraulic systems in marine applications. So applications, ships use hydrostatic forces in centrifugal pumps to transfer fluids like fuel, oil, and seawater. Usually not centrifugal pumps for fuel and oil. Usually these are positive displacement pumps. So example, in a ship's bilge pump system, hydrostatic pressure differences help drain excess water from lower compartments to prevent flooding. So there are different types of pumps all over our ship. We have cargo pumps, centrifugal pumps, tank mount pump, screw pump, gear pump, so another one type, one screw pump, piston pump, water separator, there's also a pump in here, sewage for sewage treatment also uses pump, control C, energy, deep well centrifugal pumps. Okay, another application of hydrostatic force in marine engineering is for lube oil and fuel oil purifiers. This is the purifier, as you can see. So uses hydrostatic pressure and centrifugal force to separate water and contaminants from fuel or lube oil. So the heavier water and dirt move outward due to centrifugal force, while the cleaner oil remains in the center and is discharged on the clean oil outlet. Number 9, we have the freshwater generator or evaporator with vacuum type, vacuum distillation. So application converts seawater into freshwater by reducing pressure to lower the boiling point. So we have to use vacuum pressure in this one to lower down the boiling point, which is usually at around 40 to 45 degrees. You can already create an evaporation of water. So how it works, hydrostatic pressure is reduced using a vacuum, causing seawater to evaporate at a lower temperature, which is then condensed into fresh water and then can be used on board ship. Okay, another application of hydrostatic force in marine engineering is for hydraulic steering gear system, as you can see in here. So uses hydrostatic force in the hydraulic cylinder to move the ship's rudder. So pressurized hydraulic oil moves piston inside the steering gear system, generating the force required to turn the rudder. Another application is for engine cooling systems like keel coolers and heat exchangers. So application maintains optimal engine temperature using hydrostatic pressure driven coolant circulation. So engine coolant flows through heat exchangers or keel coolers where hydrostatic pressure ensures proper heat transfer to seawater or fresh water. Another application is for bilge and ballast pumping system. So removes unwanted water from bilges or adjusts the ship's stability using hydrostatic force. So bilge pumps use pressure difference to remove water, while ballast pumps manage weight distribution to maintain stability. So this is for our bilge pump, and this is for our ballast pump. Okay, another one for boilers and steam systems. So it uses hydrostatic pressure to maintain water levels and generate steam for shipboard power and heating. So water inside the boiler is heated like this one, and the hydrostatic pressure helps regulate steam formation and circulation. Okay, so that's it. Whew. So I hope you learned something today, and that's for application of hydrostatic. That is for hydrostatic force in marine engineering. Okay, and I hope to see you in the next one. So let's see what this picture is. So what society thinks I do? They think I'm just drinking alcohol and having smoking all day long. What my mom thinks I do, and what my friends think I do. They think that I'm just enjoying my life. What the chief officer thinks I do. Oh, you're an officer. They think that you're just sleeping. And you, what do you think? What I think I do? I think I'm in a war. But in reality, what I really do is doing chipping rust. So sad, but to some or to most people, most seamen, it's true. Okay, so I hope you learned something today, and I'll see you on the next one.